Okay, Dr. Locke, I think we can
Yes,
start the seminar now, yeah?
yes, sir.
Okay, good morning, everyone. Welcome to this WEM Seminar Series 4. And this seminar, I and Dr. Locke jointly facilitate. Yeah, my name is Sangam. I think all of you know me. So I'm also the faculty in Water Engineering and Management program. And I'm also working with Dr. Locke. Okay. And in this seminar, we have two speakers, as always. And I would like to briefly introduce the two speakers. So let me share the screen. Okay, so one of the speakers is Mr. Divesh Khadka. And he's from Nepal and currently a PhD candidate in water engineering and management. He's already on the verge of, PhD degree. Perhaps he will graduate very soon. So he will be talking about simulation of Southeast Asian summer monsoon in the climate models. And the major, objective of this research is to evaluate the general circulation models from two projects, CMIP 5 and CMIP 6. And he will explain in details in his presentation. His research interest includes water resources modeling, hydrometeorological extremes, climate change impact assessment, and climate risk management. He's also working in, some of the projects of water engineering and management. Perhaps he will introduce by himself. Another speaker is Miss Kalaya from Prapan. Actually, she had just graduated in May last month. And she will be presenting her research entitled Mapping Crop Water Use Efficiency and Yield Gap Analysis using the remote sensing methods in one of the basins in Thailand, which is called 𝐴 Basin. Kalaya's research interest is related to crop water use efficiency, crop yield estimation, temperature deficit, vapor pressure deficit, NDVI fraction, photosynthetically active radiation. So each speaker, they will have about 20 minutes for their presentation. And after each presentation, we will open the Q&A session. Perhaps we can take a few questions, probably 10 minutes for each presentation. Sorry, I think there was some internet connection problem. Can you hear me now?
Yes, yes, we can hear you now.
Okay, good. Okay, so this seminar is being recorded and also broadcasted live in our Facebook page, WEM Facebook page. Yeah. So without further delay, may I request Mr. Divesh to make presentation. Divesh, are you there?
Yes, sir. Yes, sir. Thank you, sir. Good morning to everyone. Let me first share my screen. Are you able to see my screen?
Yes, yes, we can see your screen now.
Okay, great. So, good morning to everyone again. My name is Divesh, as Professor Sangnam already introduced. I'm a PhD student in water engineering and management. Today, I will make a very short presentation on simulation of Southeast Asian summer monsoon by the climate models. This research is a part of my doctoral thesis, and it is also a part of a project I'm currently working on. The project is titled Enhancing Resilience to Future Hydrometeorological Extremes in the Moon River Basin, which is located in northeast of Thailand. So with this, today my presentation outline will include some basic information on research background, the objectives and scope of the study, with some brief description on the study area, the data and methods that I have used in this research, and the major results and discussions, major findings of this result with some conclusion at the end. So let me start with the climate models. Climate models are tools that are used to simulate the climate system for various applications. And one of its major use is to assess the future climate under the anthropogenic activities. However, these climate models are also a source of uncertainties of future projections, as many studies have shown that the climate models are one of the major source of uncertainty related with the future projections. It would be followed by the assumed future emission scenarios, downscaling method of the climate data. And if you're applying these climate models for hydrological applications, then some of the uncertainties will come from the hydrological model as well. But the primary source of these future uncertainties is related with the climate models. And these uncertainties mainly come because of imperfect representation of physics in the climate models. As we know that climate models are a very complex system. And in these climate models, we are trying to simplify these physical processes that is actually happening in nature. And as of now, the climate models are not able to simulate all the features, all the processes that actually occurs in the atmosphere and other components of the climate system. So because of this, we have these uncertainties due to uncertainties related with the climate model. And as of now, there are over 100 climate models available from CMIP 5 and CMIP 6. And with these large number of climate models available, there is always uncertainty among researchers to choose which model. It's computationally not practical to use all of the available climate models for future projection. So there has to be some basis that we can use to select these climate models for the impact studies. And basically, there are two approaches that can be used to select the climate models. First one is by assessing how these climate models perform during the reference period. So some of the researchers have used this approach for selecting the climate models. And one of the recent approach is to encapsulate all the possible range of future projection by the climate model. So there are also some papers you would be able to find in which this approach has been followed. But majority of researchers still go with the previous one by assessing how the climate models perform during the reference period and assuming that the performance of these model will not change under the external forces in future. So we can see that some models could be better at resolving the regional climatic phenomena than others. And this is the basis that I have used for my research. Now, you'll be able to find several recent papers in which the researchers have evaluated the CMIP 5 climate models, like few of them I have mentioned here. But one of the limitations of these studies are that most of these studies are focused on the surface variables. It could be temperature or rainfall. Basically, these are the output variables we normally use for climate and hydrological application. But the true fidelity of model and how well it can able to simulate the climate system is better represented on how the atmospheric circulations are simulated in the model. And if the model can simulate the climate system, then they can produce the robust response to external forces in the future. So that is why it is important to consider the large-scale circulation that is driving the regional climate, in addition to the output variables such as temperature and precipitation, while doing this kind of analysis. Now, the main objective of this research was to evaluate the ability of climate models to simulate the summer monsoonal rainfall in the Southeast Asian domain. So I have selected the Southeast monsoonal domain for this study, and only the summer monsoonal rainfall is considered because the rainfall that occurs between May to October, that represents about 85% of the annual rainfall. So if a model can simulate the summer monsoon well, then that is the dominating characteristics of climate in this particular region. And in this study, I have evaluated 28 CMIP5 and 32 CMIP6 climate models. I have used 25 matrices for assessing model performance. Among them, 5 are based on rainfall, how the model are able to simulate the rainfall cycles and the onset and retreats of the monsoon rainfall. And other 20 matrices are based on large-scale circulation that I will discuss later. And with these matrices, I have used a multi-criteria decision-making technique called compromise programming to rank the climate models in each phases of CMIP. Now, the figure here shows the study domain for my research. Now you can see that the smaller rectangular box represent the area or the domain in which a rainfall was evaluated. It largely covered majority of Thailand, some portion of Cambodia, Laos, Vietnam, and Myanmar. And the atmospheric circulation or the atmospheric variables were evaluated in the larger domain. I have considered this larger domain because the large circulation within this domain affect the rainfall here. For example, during summer, from May to October. So from May to October, the monsoonal winds from the Indian Ocean moves from Indian Ocean towards northeast direction, and it brings heavy rainfall in the study domain. Whereas during the winter season, from November to February, it's called the winter monsoon, in which the dry air from South China Sea moves here, and it basically doesn't bring much rainfall. So in the study domain, the climate is governed by the South Asian monsoon, and the majority of the annual rainfall occurs during the summer period, during May to October. Like I said, about 80 to 85% of annual rainfall occurs during this period. Whereas the winter monsoon that prevails from November to February are relatively dry. So for the data sets, I have considered 4 global rainfall products, ERA5, GPCC, and CMAP. And in the study domain, these are the annual time series and the monthly rainfall. As you can see that the 3 of the products, ERA5, GPCC, and GPCC, they are quite closely related and have a good correlation among them. Whereas CMAP, although it still follows the temporal pattern, it kind of underestimates the rainfall compared to the other 3. And on the figure on right-hand side, you can see that the majority of rainfall, like I said before, occurs during May to October. So with this, I have considered ERA5 rainfall product during the analysis. And in addition to rainfall data, I have considered some other variables like zonal and meridional winds, geopotential heights, temperature at 3 pressure levels, 200 HPA, 500 HPA, and 850 HPA. And all these atmospheric variables are taken from ERA5 reanalyzed data sets. And in addition to this, I've also considered the specific humidity at 850 HPA. Now, same variables, same of these atmospheric and rainfall variables were also taken from 28 GCMs of CMIP5 and 32 GCMs from CMIP6. Now, let me talk something about the matrices that I have used for the model evaluation. First set of metrics analyze how well the models are able to simulate the annual cycle of rainfall. So I've considered three matrices. First one is Taylor score. It is basically a correlation. It's basically related with the correlation and the standard deviation of the simulated rainfall by GCMs compared with the observed data. Second matrix that I use is the monthly average root mean square error between the simulated rainfall by GCMs and the observed data set. And third one is the percentage bias in the annual rainfall. Now, another most important, I would say, most important sets of matrices that I have used is how well the climate models are able to simulate the onset and retreat of the summer monsoon season or the rainy season. For this, I have used the method proposed by Noskai and Misra, which basically use cumulative daily rainfall anomalies. As from the figure, you can see that the onset is defined as a day after the cumulative daily rainfall anomaly reaches the minimum. And the retreat date is defined as a day in which the CDRA reaches the maximum value. And the length of a rainy season is between the onset and retreat periods. Now, third sets of matrices evaluates the large-scale atmospheric circulation. For this, I have used 20 matrices. And these 20 matrices are based on point-to-point spatial correlation between the atmospheric variables from the climate models compared with the ERA reanalyzed product. Also, the monthly root mean square error between the variables. In addition to this, I have also considered the horizontal moisture flow convergence, MFC, at 850 HPM. It basically try to measures the movement of moisture within the study domain. Now, to summarize all the variables and the matrices in the table, you can see that I have used 5 matrices: rainfall, zonal and meridional winds, geopotential height, temperature, and specific humidity. Except rainfall and specific humidity, all of these other variables are considered at 3 pressure levels and in monthly time scale. Rainfall are considered both on daily and monthly. Daily are used for finding the onset and retreat dates, and monthly are used for the other 3 matrices. With these altogether, 25 matrices has been used. Now, the large scale atmospheric circulation matrices are produced by averaging the monthly values during the rainy season. And the zonal and meridional winds are further averaged to have a single matrix. Now, let me go into the result and discussion. Now, this figure here try to show the results in terms of how well the models are able to represent the annual cycle of rainfall. So 3 figures on the left-hand sides are the performance of CMIP5 models, and 3 figures on right-hand sides are for CMIP6 models. And the first sets of figures are their performance on Taylor score, second is for RMSE, and third is for the percentage biases. And from this figure, you may not be able to see a very distinct differences between CMIP5 and CMIP6, although there is a marginal improvement in CMIP6 in terms of Taylor score, but RMSE looks similar, and some significant reduction in the percentage biases in CMIP6 models. To reflect these changes in terms of model by each of the modeling centers, I have compared the climate models in CMIP5 and CMIP6 coming from the same modeling center. So altogether, I have taken the 15 modeling centers and compared the models they represent in CMIP5 and CMIP6. So you can see that in majority of models from these modeling centers, improvements are seen in Taylor score. For example, major improvements are seen from the models from CMCC, CISRO, EC-Earth, IPSL, MOHC, MRI, right? In all of these 3 matrices. But there are some GCMs which didn't improve much in CMIP6 compared to CMIP5. Like you can see that BCC, this is, I suppose, Beijing Climate Center. So we can see that the Taylor score, in fact, decreased in CMIP6. Similarly, RMSE, in fact, increased along with the P biases. So in general, the majority of the models in CMIP6 have improvement over the preceding models in CMIP5, but there are some exception cases. And when we do the ensemble average for all of the 𝐶MIP5 and 𝐶MIP6, you can see that there is a distinct improvement in Taylor score in 𝐶MIP6. Not much in terms of RMSE, whereas the p-bias, percentage bias in 𝐶MIP6 has decreased. So these sets of figures show how well the climate models are able to represent the onset and retreat dates of the rainy season. The blue bar here represents the observed onset and retreat dates. The onset date is close to 1st of May, and retreat dates is somewhere, I think it's between, could be 16th or 17th of October. And one thing we can see here is that majority of the models, I would not say all, but majority of the models, they are simulating the onset date later. So the onset date by climate models are simulated late, whereas the retreat dates by most of the models are simulated early. So in fact, what the climate models are doing is they are simulating the length of rainy season lesser than what is actually observed. So in terms of each modeling center also, it can be seen in this figure. So like before, some of the models from CISRO, INM, IPSL, MOHC, MIDOC, MRI, they show improvement in the simulation of onset and retreat dates. Like the deviation of onset date compared to the observed in these models are lesser in 𝐶MIP6 compared to 𝐶MIP5. Whereas the length of the rainy season is also better simulated in 𝐶MIP6, as can also be seen by the ensemble average of 𝐶MIP5 and 𝐶MIP6. Now for the large scale atmospheric circulation, I didn't present the result in detail. What I'm showing here is the results for results at 850 HPA. So first figure on the top shows the spatial correlation of the 𝐶MIP5 and 𝐶MIP6 model ensemble. We can clearly see that 𝐶MIP6 model ensemble is performing better in terms of spatial correlation for all of these atmospheric variables: winds, geopotential, height, temperature, and most significantly for the moisture flow convergence. Similarly, the root mean square error in 𝐶MIP6 have also reduced compared to 𝐶MIP5. So we can, overall, what we can say is that the models in 𝐶MIP6 are better able to represent the atmospheric variables, which in turn represent the atmospheric circulations that is driving the regional climate of the study domain. Similarly, they are also better at representing the rainfall, the spatial and temporal patterns of the rainfall than their producing models in 𝐶MIP5. So the improvements in 𝐶MIP6, they can be attributed to several reasons. For example, the 𝐶MIP6 models have better spatial and vertical resolutions. Like among the 28 models that I have considered from 𝐶MIP5, only 2 of the models have the spatial resolution less than or equal to 100 km. Whereas in 𝐶MIP6, there are, if I remember correctly, 16 models which have the spatial resolution less than or equal to 100 km. Similarly, the number of vertical resolutions in 𝐶MIP6 are almost double than in 𝐶MIP5. And some of the other reasons that could be attributable to the improved performance of 𝐶MIP6 are the new shallow and deep convection scheme in the atmospheric components, the updated radiative schemes, better aerosol parameterization. And these I have taken from the several studies which says that 𝐶MIP6 models are the improvement over 𝐶MIP5 models. Now, these two tables shows the ranking of the climate models in 𝐶MIP5 and 𝐶MIP6 based on the 25 matrices and the multi-criteria decision-making technique that I have used here. So in 𝐶MIP5, we can see that AMPI, CES, CCSM, MIDOC, CMCC, these are the top performing models. Whereas in 𝐶MIP6, ECR, NORCIM, had GEM, these are the top performing models. And if you see that the models from ECR, CMCC, had GEM, this MOHC, they are common in 𝐶MIP5 and 𝐶MIP6. And when I try to rank all of these 𝐶MIP5 and 𝐶MIP6 models together, I found that 12 models out of 15 top models are occupied by 𝐶MIP6 models, and only 3 of these models they will come in top 15 models when both of these ensembles are evaluated together. So these results I haven't shown here. Finally, I would like to show the composite maps of 5 best and worst performing models from CMIP 5 and CMIP 6. So let me guide you through these whole sets of figure. So let's focus on the first 3 figure on top left hand side. So these 3 figures are the observational data sets taken from ERA5 for the month of May, August and October. The May is the development of the rainy season or the summer monsoon, August is the maturation, and October is the weakening phase. So the shaded area shows the monthly rainfall during these months, and these arrows are showing the wind vectors, and these lines are showing the geopotential height at 850 HPA. Whereas if you look into the second 3 sets of figure on left hand side, these are the model ensemble of top 5 best performing models. And the shaded area represents the differences of the annual rainfall by the best models compared with the ERA5. And the third 3 sets of figures show the performance or composites of 5 worst performing models from CMIP 5. So we can clearly see that the biases are represented in rainfall by the best models are lesser than the worst model. Like you can see that in general, all of these models are showing a little bit of dry biases. It can be seen by this dark orange color, particularly in our study domain. And if you look into this maturation phase, let's look into this August month. So you can see that the biases represented here in the study domain is less than the biases represented by the worst sets of model. Now, similar can be seen in these 6 figures, I would say in the right hand side. There are 2 key messages we can take from this figure. One is that in all of these figures, the biases are lesser than what we have seen in the CMIP 5 models. That is one thing. And second thing is that the best performing CMIP 6 models have lesser bias compared with the worst performing models from CMIP 6. Like if you look into August, for example, the biases in the study domain here is lesser than here. So overall, we can see that the CMIP 6 best models are performing better than CMIP 5. And in both phases, the best models composites are better than the worst model composites. So with these results, there are some conclusions that we can make. First is that the all climate models are not equally skilled at simulating the regional climate, as we can see that some models are performing better than the others. And CMIP 6 climate models are better at representing the annual rainfall cycle, although we have seen that both sets of models are showing the dry biases. And similar improvement in the performance in the large scale variables are also seen in CMIP 6 models. More importantly, CMIP 6 models show improvement in simulating the onset and retreat of the rainy season. For example, out of 32 models considered in CMIP 6, 14 of them have the onset date within 5 days of observation, which was only 5 out of 28 models in CMIP 6. And similar improvement can be seen in CMIP, in the retreat days. This is particularly important for the future projection, because if you are saying in the future that the rainy season will shift by this day or will delay it or will be early, then we would like to base those results based on our better performing models. Because for example, if you look into the agriculture sector, the crop calendar would most likely synchronize with the rainy season. So if there are any changes in the rainy season that we would like to report, then it should be based on the best available information, I would say. Finally, the identified rank of climate models, they can be taken as basis for selecting the models while doing the future projection, at least in the Southeast Asian domain, where the South Asian monsoon prevails. So with this, I would like to conclude my presentation. Thank you, and I would be happy to take any questions regarding my presentation. Thank you.
Okay, thank you, Vivek. That's very comprehensive presentation. So now I would like to open the floor for questions, comments, or any suggestions. I again would like to, emphasize that the WEM seminar series has been organized to expose what are the research we are currently conducting. And also from these all presentation, the students learn about the research methodology, the communication skills, and also the tools and techniques that you need to use. Yeah. So yeah, if you have any questions, we can take few questions. So please unmute your microphone and you can ask directly to Divesh. And yeah, I can see Sonu. Do you have any question?
Yes, sir. Good morning, everyone.
Yeah, can you
my
turn
question
on
is,
your video?
okay, sir.
Yeah.
Yeah.
Yes,
Hello.
please go ahead. Yeah.
Yes, sir. My name is Sonu Kumar, sir, and I'm the student of the OM student itself. My questions is related to the spatial correlation you discuss about the point to point spatial correlations. But �C𝐚𝐸X5 and �C𝐚𝐸X6 all model have a gridded data. So how did you convert grid to the point? My question is that. And second question is related to the selection of the precipitation data. Like you have compared the monthly basis, like monthly temporal plot of the 4 precipitation data set, and based on that you selected the ERA5.
Yeah.
So did you compare with the observed data as well? You just compare within the reanalyzed data set?
Yeah. Okay. Thank you, Sonu, for the question. First is how I did this spatial correlation, right? So yeah, I agree that different models in 𝐶IMI5 and 𝐶IMI6 had different resolution. So before I do this point-to-point spatial correlation, what I did was bring all those climate models in same resolution. So I have brought all the GCMs from 𝐶IMI5, 𝐶IMI6, and the reanalyzed observed rainfall data at I think 1 degree resolution. Sorry, 1 degree resolution. So once all of them are in same resolution, then it will be the simple correlation analysis using Pearson's correlation coefficient. Okay, so this would be the first question that you raised. Second one is about the data set that I have used, right? So I have used these 4 rainfall products, and basically why I didn't compare them with observed data is my study domain is quite large, right? If you can see that it not only covers Thailand, but includes some part of Myanmar, Laos, Cambodia. So to get the station-based observed data in those locations would have been difficult. And what I did was I compared these data, the available gridded data products, and see how well they are matching. So you can see from these figures that 3 of these data sets, they have a good match with each other. So this shows that this ERA5, GPCC, and GPCC, they are consistent among each other, and also the rainfall, the monthly rainfall patterns are well captured by all of these rainfall products. And one more consideration that I did was, since I'm taking the atmospheric variables from ERA5 reanalyzed product, and based on the rainfall performance as well, I have decided to go with ERA5.
Okay, so thank you, sir. Actually, your main consideration was only to capture, like you just find how many of the precipitation product have a similar performance, and so you try to. Okay, sir. Thank you, sir.
Yeah.
Okay, thank you, Sonu. Okay, any other questions from the students? I think there are many students. They are conducting the research now and also preparing the proposal for the thesis maybe next semester. Yeah, so I highly encourage you to put your questions.
Good morning, sir.
Okay, Sanjay, please.
Yes. Good morning, everyone. My name is 𝐤𝐚𝐞 and I'm currently a PhD student in Water Engineering and Management program. First of all, I would like to thank Divesh for the very comprehensive presentation. So I have one question related to the uncertainties. So you clearly mentioned that climate models are the primary source of uncertainties for future climate projections. And I think that there are lots of issues related to uncertainty. Like we are also facing many problems related to uncertainty, and like we are in trouble, like how to quantify those uncertainties. So have you done any analysis to quantify the uncertainties of the climate models?
Yeah, thank you, Sanjeev, for the question. I think the best way to quantify the uncertainty would be take all the models so that we will be able to capture the whole range of uncertainty, right? But from practical perspective, it might not be convenient to use all of the available climate models since we have lots of over 100 climate models. So, like I said in one of my slides, that there are two ways. Like one way is to see how the models are performing during the observed period. And the assumption of this method is that the model performance will be similar in the future period. By this method, what we are trying to do is select only the best performing models and try to narrow down the range of uncertainty, right? But recently you will find several papers, like I have mentioned here, like they have developed a new method in which we will be able to encapsulate the whole range of future projections by different climate models by taking only few of them that are giving the extreme results. So if you look into some of these papers, you will be able to see that this method gives you an idea on selecting the minimum number of climate models while capping the whole range of future projection. So that would be my response.
Thank you, Devesh.
Okay, thank you, Devesh. Okay, one last question, because we have another, speaker also, and if we have, time remaining, then we can discuss. Yeah, Dr. Locke, is it okay to give priority to students? Yeah.
Yes, sir.
Great. Yeah. So, any questions from the students?
Hello. Hello, everyone.
Yes.
Hi.
Can you hear me?
Yes.
Yeah. Yes.
Yes.
First of all, I would like to thank Devesh Dai. This is me, 𝐊𝐴𝐧𝐠 𝐁𝐚𝐬𝐢𝐧, for the comprehensive research. It was quite informative for me. One thing I was looking for was about the downscaling or bias correction, which was not mentioned within the whole PPT. This research was conducted using the data after bias correction or without doing any kinds of bias correction. If it was done, what kind of impact you see before or after? Or if it was not done, then what could be the kind of impact in the present result if it is done so? So any insights on this would be very informative for me.
Yeah, thank you, Subhas. Actually, the objective of this research was to evaluate the performance of raw models, because once you do bias correction, you are changing the data, right? You are modifying it.
Yeah.
So you may not be able to actually capture the true performance of model once you do the bias correction. For example, let me give an example of bias correction using quantile mapping. So you will be matching, or you will be correcting each quantiles of the rainfall. So once that is done, your rainfall products from all models will be similar, right? So the mean will be similar, standard deviation will be similar. So there will be no point of analyzing the model once you do, or once you apply some kind of correction to the raw data. So in this research, I have considered the raw data, and I'm not sure how it would the performance would change once you do the bias correction. But again, like I have considered several variables, and it may not be practical to bias correct all those variables, because we normally do bias correction for the surface variables, right? Yeah. And like I said, once you do the bias correction, the true characteristics of model will be lost because you are modifying the data. So you may not be able to actually compare the true performance of the models. Yeah.
Thank you. Thank you so much.
Okay, thank you, Devesh. Dr. Locke, maybe let's keep the questions at the end of the presentation. Yeah.
Yes, sir, definitely.
Yeah. Shall we go to the next speaker? Okay, thank you, Devesh. And
thank you, sir, for giving me the opportunity to present today. Okay, I will stop sharing my slides now.
Yeah, let's give him a big round of applause. Yeah. Okay, so before we move to next speaker, probably we can capture the photos in the screen, right? Ruel, are you ready to capture the photos of the screen?
Yes.
Yeah,
okay.
may I request everyone to turn on your video?
Yeah.
It looks very fantastic. I think we have two panels, right? Ruel, you have to do panel number 1 and panel number 2. So, okay.
Yes, sir.
So everyone ready? 1, 2, 3.
One more.
Okay, one more.
Next panel 2.
Next panel 2, right? So everyone, okay, 1, 2, 3.
Okay, done.
Okay, thank you very much. So let's move to our next speaker. Our next speaker is Miss Kalaya, and she just graduated from AIT, Water Engineering and Management Program. So Kalaya, congratulations. I think you are one of the, 14th graduate from Water Engineering and Management Program in one of 135th graduation ceremony, right? So congratulations. And she will be presenting about mapping crop water use efficiency and yield gap analysis using remote sensing methods in one of the basins in Thailand called 𝐴 Basin. Okay, so Kalaya, please, you can share your PowerPoint and you have about 20 minutes. Okay, yeah. Thank you.
Good morning, everyone. Can you hear me? Hello.
Yes, we can hear you.
Yes, we can hear you.
Thank you for Dr. Pulakam that invite me to present my about thesis topic. For my thesis topic is mapping crop water use efficiency and yield gap analysis using remote sensing method in the 𝐴 Basin, Thailand. For the topic outline, I consist of the introduction, objective, study area, data collection, methodological framework, result and discussion, conclusion and recommendation. For my background is why I need to do the thesis topics, because in my basin area has amount of water resource which can lead them to have plan to use continuous irrigation pattern into the delivery water in the main canal and the sub-main canal. Moreover, they don't have plan. They have plan to increase the fresh water to helping the decrease the wastewater in the Chao Phraya River in the Chao Phraya River, Bangkok, Thailand. If they have this mapping, it can help them to decide this of management of water resource for the agricultural area. And this is for my assessment of this problem, because irrigation water is important to the agricultural economic area. That is difficult and slow for the getting the real-time crop data of agricultural plan. And nowadays we can apply the satellite image for estimating crop yield and actual crop water use by calculating the actual evapotranspiration. And this is my objective consists of the reconstructing cow contaminant missing the NDVI value using the harmonic time series model and predicting crop yield at field scale using the land use efficiency energy balance model and assess crop water use by estimating crop evapotranspiration throughout the simplified surface energy balance model and mapping spatial variability of crop water use efficiency and yield gap to assess the crop productive cropping system in the basin. And this is for my scope of work. I collected climatic data set from the TMD at Thailand, and I collected the crop yield data set from the Office of Agricultural Economic and the GISDA organization. And I retrieving cow contaminant pixel and NDVI value from the harmonic time series model and predicting crop yield as biomass by using the land use efficiency model and predicting crop yield by harvesting index as biomass using the linear relationship function. And next, I estimate the crop water use of evapotranspiration using the simplified surface energy balance method and develop converter use efficiency map by raster overlay operation from the GIS and Google Earth engine. And this is my study area. For my study area can separate into the 3 parts. The area in the north part is almost the forest, and the center part is the plain area which has a lot of crop plant in this area, and the below part is the estuary that has problem about the soil, the salt intrusion. And in addition, my area is have the one irrigation project to manage the water resource, which come from the Wachiralongkorn Dam and Sinakharin Dam. And this is my data collection. For my data collection, I have to collect the rice field and sugar cane field from the GISDA organization, and next I need to collect the kinematic data from the TMD Thailand to calculate the gross primary product and reference evapotranspiration in terms of daily. And next, this is for my overall my work. I had to separate into parts for my 4 objectives. The first part, I have to develop the NDVI by using the harmonic function for calculating my 𝐸𝐷. Because why I need to develop NDVI, because of the Landsat image are affected by the cloud contaminant. And this seasonal pattern from the NDVI value can be visualized in terms of the harmonic function signal with amplitude and phase parameter consist of the constant and coefficient overall trend of the time factor, coefficient and coefficient for sine and cos function at time frequency angle. And the next objective, I want to find the 𝐸𝐷. In terms of my 𝐸𝐷, I need to calculate the gross primary product first. For the gross primary product, depend on the par, F par, FT, and FVPD. These are vary from the environment condition. For the par, yes sir.
Yeah, can you use the pointer? I think you can right click on the screen and select the pointer options. Yeah. Pointer options, go down, down, and then,
Yes.
Okay, yeah.
For my gross primary product can depend on the par, FT and FVPD and F par. For the par is either 40% of the shortwave solar incoming in the Thailand, and the FT is the temperature deficit, which can calculate from the daily temperature and max and min temperature. And next, FVPD is the vapor pressure deficit, which can calculate from the daily vapor pressure deficit and max and min daily vapor pressure deficit. And next parameter, F par is the fraction of the incoming solar radiation in the photosynthetically active radiation spectral region that is absorbed by the photosynthetic organism. The light absorption across that can be used as the indicator of the stage and evolution of the vegetation cover. For my F par calculate from my NDVI that I had already applied harmonic function time series for my NDVI value. And my NDVI value is vegetation index of plant that is varying from the -1 until 1. If high value, it can show that the area has dense of plant, and if low value, it can show that the area is the bare soil. And the next objective is, I want to assess the actual crop evapotranspiration by using the 𝐊𝐴𝐴𝐴 image to calculate the ET fractional and ETO. For the actual Hop evapotranspiration will depend on my the fractional evapotranspiration and reference evapotranspiration. And then for the next objective is the when I already got it the crop yield prediction and water use and actual water use, I will got the crop water use efficiency mapping on the objective 4. And next slide. I will show about the result and discussion. This picture I will show about my location, which can represent the result of gap filling and NDVI record value. S1 and ST are sugarcane field on the 2015 and 17. R1 and RT was the light field on the 2015 until the 2015 and 2017. And next slide. This is the result. My result. Can show that the sugarcane crop. This is the sugarcane crop has less value of the RMSD. It means that this location of sugarcane close to the seasonal crop, that is start planting on the May until the next year May. Similarly to the light field crop. There are a little different value of the RMSE, but tend like almost the same season crop. We start planting on the July until the November. And the next slide. Is the result and discussion. This result I want to show how each parameter can calculate in the gross primary product value on the light and sugarcane field in the specific season on the 2015. The season of light field was calculated from the July until the November, and sugarcane was calculated from the May until the next year May. This map was show parameter of PAR and F-PAR. The variation of PAR were close to the maximum value. Maximum value over the 2 district area, which in the length from the 0.8 until 1. But however, F-PAR value were very special over these 2 districts. This is due to the variation in the NDVI over the space, which can make the corresponding change in the F-PAR value. And the next result I want to show, and the second map will show the parameter of TD and BPD. I can find that average temperature deficit over two distinct areas were not varying, and it had length from 0.4 until 0.6, and whereas the vapor pressure deficit map over 2 districts were showing some different value. It length from 0.4 until the 0.6 on the Phnom Penh district and 0.8 until 1 on the Ban Song district. And the next result I want to show, and it can be seen that the F-PAR was more effect on the gross primary product because of this map. I want to show the gross primary product in the Phnom Penh district and Ban Pong district. It can be seen that on the Ban Pong district there are varying value of gross primary product around 0.6 until 0.9, more than the Phnom Penh district. Because of F-PAR parameter as can result in the gross primary product more than the another parameter. And the next result, This map is the same condition for showing the result of PAR and FPAR in the sugarcane crop. The calculated PAR were close to the maximum 0.8 until 1, while the FPAR value were very vary from the 0.2 until 1 across both two district areas because of fraction of photosynthetically active radiation was modeled as a function of NDVI variation across these two district areas. And the next result, I show about the temperature deficit and vapor pressure deficit for the sugarcane crop on the 2015. The results show that the TD value was not changed over the two districts, but VPD value will change over these two district areas. And this map, I will show about the gross primary product of the sugarcane field that they are planting on the May until next year May over these two district areas. The result can show that the calculation, the gross primary product value, they are ranking from the 0.6 until 0.9 kilogram carbon per square kilometer in the both two district areas. This clearly show that the gross primary product accumulation relatively similarly to in the both two district area, although there were some validation in the mean BPD across these two district study area. And next, this graph will show about the calibration of harvest index for the calibration of harvest index for the live field in the 3 year 2015 until the 2017. It can be seen that there are the good correlations. There are the good correlation for the live field, and there are the low good correlation for the sugarcane field. And next, this picture I show about the my validation yield into district area at the right field. I can find that for the Phnom Penh district has value around 0.2 until 0.4 in the center part of the area, but Ban Pong district has value around 0.3 until 0.5 kilogram per square kilometer, which has more value than the Phnom Penh district area because of light field in the Ban Pong district was fully gold in the good condition of the light use efficiency model. So, and next, this picture I show about the my variation yield into district area of the sugarcane on the 2015. I can find that these two districts had nearly value the crop yield. That crop yield was varying from the 5 until the 18 kilogram per square kilometer. And this graph I show about the comparison of predicted yield and the observed yield for the live field on the 2018 until the 2019. There are the good correlation between live field on the 2 years. And also next two graph, I will show about the comparison predict yield and observed yield of the sugarcane field on the 2018 and also 19. It can be seen that for the overall live field and sugarcane field in this year, there are the good correlation. There are the good correlation between observed yield and my yield prediction. And next, I will comparison of the yield model and statistic model which come from this data. It can be seen that from the my yield model has more value than the my observed yield because of my yield model will calculate from the gross primary product that conclude the total material of the planting growing. It can be seen from this graph. This graph I also show the statistic model 𝐾OBE model and my yield model from the live field on the 2018. This is for the sugarcane 2018 and this is for the sugarcane 2019. Yes, sir. And the next picture is the and the next result image. I want to show how model to calculate the actual evapotranspiration by using the SHEM model in the two districts on the 2015. It can be seen that the ETF of line into district were close to the maximum value. It was ranking from the 0.2 until the 0.4. That value can show that and ETA was varying from the 120 until the 355. ETA was show the minimum value when the ETF was high the value, and ETA value what is the function of the fractional evapotranspiration and reference evapotranspiration. And also this graph, similar to the sugarcane field, I also select the two district area to show the variation of the ET fractional and actual evapotranspiration. We can find that the ranking of the ET fractional around the 0.1 until the 0.3, and while the estimate of the ETA ranking from the 900 until the 1000. And also this map was show about the 𝐶𝐽 water use efficiency for the live field during the 2018 and 19. I apply the same function to predict the yield and assess the 𝐶𝐽 evapotranspiration to calculate the CWUE on the live field during the July until the November season in the all area. I can find that the live field the right field 𝐶𝐽 water use efficiency were varying from the 0.5 until the 6.9 kilogram per square kilogram per cubic meter across the basin. It can be seen that the southern part of basin was show the relatively lower 𝐶𝐽 water use efficiency, while the northern part of the basin is estimated with higher water use 𝐶𝐽 use efficiency. It can be seen that the southern part of the basin has more water input in the live field area, such as rainfall and irrigation projects, whereas northern part has only water inputs which come from the rainfall. And also this map show about the 𝐶𝐽 water use efficiency live field during the 2018 and 19. Also I apply the same function to predict the yield and actual 𝐶𝐽 water use on the live field. This map during time October until the February season in the all area. I can find that the live 𝐶𝐽 water use efficiency were varying from the 0.3 until the 3.4 across the basin area. It can be seen that the southern part area has good the 𝐶𝐽 water use efficiency than the northern part because there was the water input close to the actual 𝐶𝐽 evapotranspiration, which was the main factor that can help the fully growing of the planting area. And on the next part, I want to show the 𝐶𝐽 water use efficiency. of the sugarcane field. It can be seen that for the sugarcane field, I have the more value of the 𝐶𝐽 water use efficiency. It means that for this my land use efficiency model not appropriate with the sugarcane field because of the sugarcane field needs more consume water then more consume the solar incoming to produce production of the sugarcane. And this is for my conclusion. For my conclusion, a detail of field scale 30 meter based on 𝐸 converter use or ET and converter use efficiency information were developed with help of the Landsat satellite image and remote sensing method. The developed harmonics model time series model were able to relatively the missing NDVI value, and the prediction NDVI value was precisely reflecting the seasonal variation in the rice field and sugarcane field. Light use efficiency model was able to simulate the gross primary product that's appropriate with the cereal crop such as rice more than the sugarcane crop. And next, the prediction. And next, converter use efficiency map for the rice and sugarcane field clearly indicate that the water is not efficiency due to as the value varies significantly over the space. Specifically, the southern parts of the basin where the irrigation projects are active show a low water use efficiency, and the low water use efficiency in the lower parts of the basin could be due to the overuse of the water throughout the irrigation lead to the higher actual evapotranspiration in the yield crop. And next, this is for my recommendation. Spatial resolution of satellite image is important to monitoring the crop plant. We need to use the high resolution of image satellite more than the coarse resolution image satellite. In terms of the crop yield model, should improve the gross primary product by using the NPP, because if the NPP is the rate as with ecosystem accumulate energy or the biomass, according the energy is used for the process of respiration. This is a typical correspond to the rate of photosynthetic seed minus respiration by the photosynthetic seed. The NPP may provide real biomass of the plant. And parameter of the harvest index was calibrated using model estimation got primary product value and the field observation and the field observed yield value. However, the validity of this calibration harvest index can also be verified from the field-based experiment. Yes, sir. Thank you very much for your attention, my presentation.
Okay, thank you, 𝐾𝐬𝐻. That's very impressive presentation, and also thank you for accepting our invitation, although you have graduated and you are still with us. Thank you very much. So, okay, I want to take few questions. So if you have any questions, please raise your hand or unmute your microphone, and you can directly ask to 𝐾𝐬𝐻. Okay, Sariha, do you have any questions to her?
No, sir.
Okay. Okay, Dr. Locke.
Yes, sir. Actually, thank you for 𝐾𝐬𝐻 for presenting a very, I would say, very rich information presentations. I'm not coming with a question actually, but I'll just come with a comment. I see that you have generated a lot of results, but several results are presented in the same manner. Maybe in the future, I recommend you to look at different ways to represent the results. So not only using maps, but sometimes you can use graphs, or you can use tables to highlight the differences across the similar types of results. But because you are comparing between sugarcane and rice, and then you're using the same indicators, so maybe try to diversify the presentation of the results so that the presentation communications will be improved. So yeah, so that's just my comment.
Thank you, sir.
Okay, thank you, Dr. Locke, for the comment. Yeah, any questions from the students? Okay, Sonu, do you have any question?
Yes, sir.
Yeah.
Thank you very much, 𝐷𝐿𝐼, and you have a very good presentation and you presented a very rich amount of the information. My questions is related to the 𝐺IS data software that model you use to predict the product quantity. So I would like to know that what is the efficiency of this model in predicting of the different type of crops. So basically you did the prediction in the case of the rice as well as the sugarcane. So how did you find the efficiency in different crop of this model?
I have to compare the value of converter use efficiency from my model with the reference from the FAO. Yes, sir. That's why I will know that my sugarcane cost not appropriate. Not appropriate with the use efficiency model to predict the production of the sugarcane field.
That means this, yeah.
Yes, yes. But for the life field will appropriate with the use efficiency model more than the sugarcane field. Yes.
Okay. So basically, it's also depend on the type of crops, like which crops you are using for predicting with the help of the GIS data model, right?
Yes, it's specific.
So my second question is just a little bit about this model, because this model is very interesting because it have a very good correlation with the observed rice production. So what are the inputs which required for this model?
I will tell you. I have the two models. The first model I need to predict the crop yield, and the second model I need to assess the actual crop evapotranspiration. For my predict the crop yield model, I need to use the kinematic data which come from the TM Thailand, and the data which come from the image satellite to combine it together to calculate the crop yield model. And next, I will convert this model to the I will convert this cost primary product model to the crop yield model by multiplying the harvest index. From the my harvest index actually need to come from the my field experiment. But for this my thesis, I find the harvest index from the yield observed and yield and cost primary product model. Yes, that's why I think I should improve the harvest index.
Thank you very much, 𝐷𝐿𝐼, for your explanation.
Okay, thank you, 𝐷𝐿𝐼. Any other questions from students? If not, I would like to thank 𝐷𝐿𝐼. So let's give her a big round of applause again. Thank you, 𝐷𝐿𝐼. Okay, so we are at the end of our seminar. 𝐷𝐿𝐼, can you stop sharing your PowerPoint slides?
Sorry.
Yeah, you can stop sharing. Okay, thank you. Okay, as I mentioned that this is a bi-weekly WEM seminar. It means that we have, once in every 2 weeks, and there will be a lot of presentation from the students in coming days. And our next date is, I think it's on June 23rd. Yeah, Dr. Locke? It's June 23rd, Wednesday, the same time, 11 to 12 Bangkok time, 11 a.m. to 12 p.m. Okay. And there will be 2 speakers for that seminar. One is Ms. Pragya Pradhan. She is a PhD candidate in water engineering and management. And Miss Parichat Pinsri. She just graduated last month. So two of the speakers will be there, and I think they are also attending this seminar. So Pragya, can you tell us briefly about your presentation topic for next seminar? You can promote your research, right? Promote yourself.
Thank you, sir. Hello, everyone. My name is Pragya Pradhan. I'm a PhD student in water engineering and management. For coming webinar, I will be presenting my master's thesis on the title Evaluation of a Soil and Water Assessment Tool and an Artificial Neural Network Model for Hydrologic Simulation in Different Climatic Regions of Asia. Actually, this this research is mainly based on the evaluation of the hydrological model and artificial neural network in 3 different kinds of the climate region of the Asia. So please, I request everyone to attend the next webinar coming on 23rd June for the detailed description of my research. Thank you.
Okay, thank you, Pragya. I think we have Parichat Pinsri, right? Emmy, are you there?
Hello. Yes, sir.
Yeah, can you turn on your video? Is it okay?
Yes, sir.
Okay, yeah.
Okay.
Yeah, so can you briefly introduce your topic?
I'm also the next presenter. Yes, sir. Yes, I will be presenting my master thesis, which is on assessing climate change, land use change, and abstraction scenarios impacts on the groundwater resources in PARC Special Economic Zone in Thailand. So all the details of the methodology and results will be discussed in the next seminar. So please attend. Please join if
Stay
you're
tuned,
interested.
right? Okay, good. Okay, thank you. Dr. Locke, do you have any announcement for the students for the next seminar?
Yes, thank you, Professor Sangam, for reminding me. Actually, I would like to remind you that we have a small competition across the presenters. So after 10 presenters, we will have a poll voting for the best presentations, and then the winner will be eligible for coupon of 2 drinks in either Intanin or the Hamgrun. That will be the prize for the winners. So with the coming 23rd of June, we will have just enough presentations then to make the poll. So do look out for the poll that will be sent right after 23rd of June. Thank you.
Okay, thank you, Dr. Locke. Okay, so I would like to thank everyone for attending this WEM Seminar Series 4. Yeah. So please stay safe and stay healthy, and we will see you in next seminar on June 23rd. Yeah. Okay, thank you very much, and bye-bye.
Bye-bye, everyone. Have a nice day.
Bye, everyone. Bye.